Lesson 5.1 and 5.2 I have combined together on one video lesson. And today what we will be doing is we will be solving one-step inequalities. The first thing that I want to look at is the 4 kinds of inequalities that we will be looking at. You are familiar with the symbols. Let me just familiarize you with the phrases that are used to describe these symbols. Okay, so first we have greater than or more than. Then we have less than or fewer than. The next one is greater than or equal to, at least, or no less than. Greater than or equal to, at least, no less than. And the last one is less than or equal to, at most, no more than. Those are the 4 inequality symbols that we will be working with, and those are the phrases associated with them. Okay, now let's look at graphing inequalities. You may remember this from pre-algebra, but I still want to review this with you to make sure that you remember how to graph an inequality. A is greater than 5. Let's start with the first one. A is greater than 5. Well, there's an infinite number of solutions to this inequality. A is everything that is bigger than 5. 5.001 all the way up to a trillion and on. So the way that we express the solution to this inequality is we shade in everything that is a solution. So everything greater than 5 does not include 5. So we draw a circle over the 5 that is open, not shaded, showing that 5 is not part of your solution set. And then we shade everything to the right of 5, which is everything greater than 5, including the arrow signifying that it's everything, on and on and on forever, that can be a solution, can be substituted for A. And let's look at the second one. A is less than 5. Again, everything that A can be has to be smaller than 5. It can't be equal to 5, so we will draw an open circle over the 5, not shaded. Okay, and then we shade everything smaller than 5, which is to the left, including our arrow. All right, the next inequality is A is greater than or equal to 5. Well, if it's greater than or equal to 5, then 5 should be shaded in because 5 is a solution to this inequality. 5 can be substituted for A, and that would be a true statement. And then we're going to go to the right. Let me write in these numbers because I think they skipped over to the other page by mistake. And here we have our last one. A is less than or equal to 5. Or equal to means that 5 is included as part of the solution, and A is everything smaller than or equal to. So we will highlight or shade to the left. Okay. All right, let's start solving. Oh, I'm sorry. Before we solve, I want to go over with you the properties of equalities. For addition and subtraction, the property of inequalities is the same as the property of equality. Okay? When you add or subtract any number from both sides of an inequality, the inequality remains true. Okay? So go ahead and write down these rules, and basically what they mean is that anytime you add or subtract any number from both sides of your inequality, notice that your inequality remains true. Okay? So there it remains the same, there it remains the same, remains the same, remains the same. So for addition and subtraction, the inequality remains true for when you are adding or subtracting from both sides of an inequality. That's not the case, however, with multiplication and division. Okay? Let's look at multiplying and dividing an inequality. When you have a positive number C, when it's a positive number that you're multiplying or dividing both sides by, then yes, the inequalities remain true. If it's a positive number, your inequalities remain true. However, when you are multiplying or dividing both sides of an inequality by a negative number, then notice what happens to your inequality. Your inequality must be reversed. Whenever you multiply both sides of your inequality by a negative number, or you divide both sides of your inequality by a negative number, you must reverse the inequality. If it was greater than, it becomes less than. If it was less than, it becomes greater than. Okay, pause the video and make sure you get these rules down on your notes. Okay, let me just show you an example to show you why it is that we reverse the inequality when we're dealing with a negative. First, I want to show you a problem. Let me give you a true inequality. Let's see. 10 is less than 8. That's a true statement. 10 is greater than 8. Let's try this again. 10 is not less than 8. 10 is greater than 8. Okay? All right, so let's just try multiplying both sides by a positive 2. Let's just do that, just as an exercise to see if this inequality remains true or if it doesn't. 2 times 10 is 20. 8 times 2 is 16. Is it true that 20 is greater than 16? And the answer is yes. So I multiplied both sides by a positive number, and my inequality remained true. Okay? Let's try this one. Same inequality, 10 is greater than 8. This time, let's try dividing both sides by a positive number. See what happens. Divide both sides by 2, positive 2. We get 5 and 4. Is it true that 5 is greater than 4? The answer is yes. So again, if I'm multiplying or dividing by a positive number, notice that the inequality remains true. So now let's look at the same inequality. 10 is greater than 8. And let's just do this exercise to show you what happens. Let's multiply both sides this time by a negative integer, by negative 2. So negative 20 here and negative 16. Is it true that negative 20 is greater than negative 16? No. No. So what you need to do is you need to bring down the opposite symbol. Negative 20 is smaller than negative 16. Okay, so notice that you have to flip the inequality. That's when you are multiplying by a negative. Let's try dividing by a negative, see what happens. 10 is greater than 8, right? All right, let's try divide by negative 2, divide by negative 2. Well, what happens? What happens as we divide both sides of an inequality by a negative integer? Well, this becomes negative 5, and this becomes negative 4. Well, negative 5 is not greater than negative 4. Negative 5 is actually less than negative 4. Again, flip the inequality to make it true. So the key is this. If you're multiplying or dividing both sides of your inequality by a negative number, you have to flip the inequality. Okay, let's continue. Let's practice. Number 1. X minus 3 is greater than 7. In order to solve this inequality, we're going to add 3 to both sides. And we have x is greater than 10. So when we write our solutions for inequalities, we're going to write them in set notation. So you need the brackets, and this is set notation for an inequality. You will say all values for x where, and that's how you read this, all values for x where x is greater than 10. And that's how we'll write our solutions. And then, of course, I want you to graph them. So we have 9, 10, and 11. So x is everything bigger than 10. So I'm going to have an open circle on the 10, and I'm going to highlight everything to the right. Okay, pause the video. Work on number 2 on your own, please. Okay, check your solution, please. All right, let's do number 3 together. Number 3. 10 is greater than or equal to n minus 1. Let's add 1 to both sides. 11 is greater than or equal to n. So let me show you how we'd write this in set notation. All values for n where n is less than or equal to 11. You're reading it this way, always with the variable first. And we'd graph it like we do all of them. This is 10, 11, and 12. And so n is less than or equal to, so we have closed circle. We're going to highlight to the left. Okay. Number 4. 8n greater than or equal to 7n minus 3. Because we have two n's on opposite sides of the inequality, we'll have to remove one n term. 8n minus 7n equals 1n, or just n is greater than or equal to negative 3. Again, set notation for all of these. N, all numbers for n where n is greater than or equal to negative 3. Right? And we'd graph it. This is negative 2, negative 3, negative 4. Greater than or equal to means closed circle, and we will shade to the left. To the right, where numbers get bigger. Okay, these were all addition and subtraction equations. Now let's go to multiplication and division. Remember to keep your eye out for when we divide or multiply both sides by a negative, that we flip the inequality. Keep your eye out for that. All right, here we go. Number 5, negative c divided by 6 is less than negative 5. So my first step is going to be to multiply both sides by 6. I'm multiplying both sides by a positive 6, so I don't have to flip my inequality there. Okay, and the reason that I'm doing that, and I don't know why I wrote 6 over 1, but the reason that I'm doing that is because I want to eliminate that denominator of 6. All right, so I'll bring down negative c is less than negative 30. Well, now I need to isolate c, and because c is being multiplied by a negative 1 there, I'm going to divide by a negative 1. Notice I'm dividing by a negative, so I need to flip my inequality. C is greater than positive 30. C is greater than 30. So again, my solution set is all values for c, where c is greater than 30. And we'll graph that. Here's 29. Here's 30, here's 31. In this case, I have an open circle on 30, and I'm shading everything that's greater than 30 to the right. Okay, pause the video, do number 6 on your own, please. Please check your solution. All right, number 7, negative 84 is less than 7v. Let's divide by 7 on both sides. Divide by 7. Notice I'm dividing by a positive 7, so there's no need to flip my inequality. So negative 12 is less than v. The way I write that in set notation would be all values for v where v is greater than negative 12. Again, I read the inequality in this case from right to left so that my variable is read first. And that's how I write it in set notation. So I have negative 11, negative 12, negative 13. This is greater than, so it'll be an open circle, and I'm highlighting everything to the right. All right, let's look at this one. Negative 3/4 r is less than or equal to negative 6. So in order to divide both sides by negative 3/4, what I'm going to do is I'm going to multiply by the reciprocal, multiply both sides by negative 4/3. Okay, so that eliminates the negative 3/4. I'm going to bring down r. Because I'm multiplying both sides by a negative, I must reverse my inequality. So instead of less than or equal to, it's going to become greater than or equal to. And here I can cross cancel, and my answer is 8. So in set notation, all values for r where r is greater than or equal to 8. And we'll graph it this way. 7, 8, and 9. Close circle on 8, and again we're going to the right. Okay. All right, let's look at this word problem. Kayla took $12 to the bowling alley. Shoe rental costs $3.75. This is supposed to be shoe rental. Write and solve an inequality to determine how much Kayla could spend on games. Let G represent the money that Kayla could spend on games. So let's think about this. When you go bowling, you have to pay for two things. You have to pay for your shoe rental plus the games that you're going to play. And that must be less than or equal to the total amount of money that you brought with you. You can't spend more than you have. All right, so let's go ahead and substitute. Shoe rental is $3.75 plus the amount of money she's going to use to play games, that's G, must be less than or equal to the total that she has, which is $12. So let's subtract $3.75 from both sides of my inequality. And G is less than or equal to $8.25. So she can spend less than or equal to $8.25. And one of the ways that you can write this is that she can spend at most $8.25 on games. That would be a proper answer. Okay. All right, do these 5 independence practice problems. Write down any questions that you have about these one-step inequalities. We'll continue working with them tomorrow. Okay, good night and God bless you.